So here we are at layer 3. We have all of those local networks already built. So now we don't really care what's going on inside of those local networks anymore. Someone's already built them. They're great. They let anyone in the local network interact. So our final step here at layer 3 is to connect up all of those local networks together to achieve global connectivity. So layer 2 allowed us to send messages to anyone nearby, for example, in the same network or in the same apartment complex. But layer 3 is going to allow us to send messages to anybody in the entire world that's connected to the internet. That's what layer 3 provides. And we'll talk about protocols here at layer 3 as well. So in the internet, we don't call them post offices anymore. We'll call them routers. And a router is just a computer sitting on the internet, and its only goal in life is to receive messages and then forward them to try and get them closer to their destination. So for example, if I have these two local networks, one at the top and one at the bottom, one thing I could do is try and cross-connect them with a bunch of wires, but that wouldn't scale very well. It would be expensive to install all those wires. It would make the protocol more complicated. So instead, what I'll do is I'll install a router, which is just a single computer. I'll hook it up to the first network. I'll hook it up to the second network as well, and it now acts like the post office. If someone up here wants to send messages to someone down here, instead of directly sending the message themselves using their own carrier pigeon or their own mailman, they can take the message and send it to the router, and then the router can forward the message to the intended recipient. So this is great. This allows us to connect up local networks using just a single router. And if I repeat this trick enough times, I can get the entire internet connected. And that's a great thing. So here's a picture of what the internet might look like once you connect everyone up. You have all these little local networks. Here I've just drawn one computer, but you could imagine there could be 10 computers here all connected in a local network. And then there's this sequence of routers that I've installed all over the place, and it kind of forms a graph. And now what I can do, if I have a message from A, who could be in California, and a destination D, who could be in France, well, what I can do is I can send the message, and even though the message may not directly reach D on the first try, I can send the message to the router, and then this router might say, I can't reach D, but you know who can reach D? It's my buddy over here. They can get you closer. So the message will get forwarded to this router. And then this router says, I can't reach D either, but if I send it to this router over here, that's going to get the message closer. So I'll forward the message here. And then finally, this router says, I can reach D. So they will forward this message to D, and D has received the message. So as we've seen, messages can take multiple hops. They can cross multiple routers before reaching their intended destination. Now, one very cool thing about the way we've built the internet so far is the layers of abstraction. So to once again show you how useful this is, when we send this message across multiple hops, it could be the case that each of these hops uses different technology. So for example, this could be a wireless link. A could use radio waves to send the message to the first router. But then this router might use a wire link to send the message to the second router. And then this router could use another wire link to the third router. And then maybe the last router uses a wireless link to the intended destination. And that's totally fine. That's happening at layers 1 and 2. So at layer 3, we don't have to worry about it. We just worry about sending messages across multiple hops, and how the message is sent, whether it's Wi-Fi or Ethernet or a pigeon, it doesn't matter to us. That's a great consequence of the way that we've built the internet. OK, so far we've been saying messages. You might have seen me trip up and say packets a couple of times. So we should be a bit more formal about a message and what it actually is. If you just send a letter, no one's going to know what to do with the letter. So if I just go to the post office and I hand them a piece of paper and I say, send this, they're going to be very confused. They need to know, where do you want to send this message? And who are you? And what allows you to send this message? So there's a lot of questions you have to answer about this piece of paper with a letter that you want to send to someone else. So when I go to the post office and I want to send a letter, I also have to specify a couple of things. I have to say who I am, so that maybe the recipient can send me a reply. I have to say the destination, where the message is going, and then I have to include the actual data. So similarly, when we send packets on the internet, they also have to include these metadata fields, such as where the packet is from and where the packet is going. So that's something that layer 3 also has to support. When you send packets, which is another word for a unit of data, you have to specify who the packet is from and where the packet is going. And each router has to then receive the packet, and either they have to give the packet to its destination, if possible, or they have to forward the packet, that is, give the packet to another router that is closer to the destination. So each router says, I can either give this packet to its recipient, or if I can't, I'll at least get it closer for you. That's what the post office promises. It will forward the packet to someone else who is hopefully closer. So that's what happens at the network layer. Routers forward packets to their intended destination, and this can scale to the entire world.